Good afternoon, ladies and gentlemen. Welcome to the university, and I would like just to give you a very brief sort of introduction, really, to the Space Centre, and that will lead into presentations from our students this afternoon on their various posters. As Martin alluded, there's been a lot of changes in the last year as we've prepared for the sell-off of the company, and many people have asked questions about what does that mean to the relationship with the university. And the quick answer is that that relationship is unchanged. It's in fact even more important, and now our sort of relationship with SSTL is essentially formalized as a business relationship between the university and SSTL. So I want to talk a little bit about that, give you an overview of our activities. As we all know, one of the trends in spacecraft technology is this trend towards smaller and smaller and yet very capable spacecraft, and that's something that we've been pursuing at Surrey now for over a quarter of a century. And having had great success in Earth orbit, we're now looking beyond Earth orbit to the Moon with the Moonlight and Moonraker mission, which you'll hear about later on today, but also over to Mars and to asteroids and even beyond. Other opportunities which are coming on stream are aspects of space tourism, private enterprise in space. Many people believe that space will take off, as it were, with the advent of private enterprise. If we look at aviation history as a sort of precursor, we see that it was only once the sort of private individuals got involved that technology really took off and became cost-effective and so on. Small spacecraft give us more opportunity to do new kinds of missions, and that's been exemplified, I think, really by the DMC mission, which has been a fantastic success. And since 2004, we've been providing humanitarian assistance in many of the world's great disasters, and it's been a fantastic success. And I note that this has been in operation now for a number of years, whereas our colleagues in the main space agencies are still talking about it. So it shows what can be done with small satellite technology and a sort of spirit of get up and go. So that's the kind of spirit that we want to encourage amongst our students so that they take that into industry and into the space community. So small satellites give us more frequent use rapidly. And we've seen the rapid eye concept. And as you know, those who remember back to the days of USAT 2, that was a 6-month program from sort of start to finish. So these can be very rapid programs. This gives us an opportunity, of course, to get the timing of space missions sort of allied to the timing of our students going through university. A typical PhD is 3 years. In that time, there are opportunities for students to have access to space programs, to see how they're working, and potentially to fly experiments and get results in some circumstance. And of course, it reduces the cost as well. And I think the next speaker will talk about the CubeSat program, which has been a fantastic program at bringing space engineering into universities worldwide. So our vision at the Surrey Space Centre is to become the world's leading research centre and innovator in small satellite technology, and we want to push the boundaries of what we can do with these spacecraft and to develop the technologies and techniques which allow us to do more with less. And of course, in doing that, we train our next generation of space scientists and space, and we hope that they will go out into industry and into the main space agencies and become a sort of advocate of the small satellite approach. We've seen with the Jove mission, actually, what can be done with a small satellite approach, even on a very complex mission. And again, that's been a great success too. So training is what we are about. I'm pleased to say that after a number of years where there have been just a few of us holding the fort, we've now come back to our full complement. And my most recent colleague, Raffaella, will join us in September, and that will then complete our complement of academics. So, of course, Professor Sir Martin is still our director and has a foot in both camps, as it were, both at SSTL and also at the Space Centre, just to make sure that synergy remains. My role is to provide the leadership of the Space Centre and to work with my academic colleagues in these various research areas. So we like to think we've got a very large spread of research which covers many different areas of space, and we are producing intellectual properties. It's called producing ideas, innovations, which sort of match what SSTL require in the future. So we see ourselves as doing the sort of future research for SSTL to exploit later. So the relationship between the Space Centre and SSTL is unchanged. All that's really changed. And so still we're answerable directly to the university. Faculty of Engineering and Physical Science, yet another change that's gone through as we've moved back to a faculty from being a school. But we still have this direct link to SSTL. SSTL exploit our IP, and we in turn get access to SSTL technology and opportunities. This is a very busy slide, but just sort of shows SSC activities on SSTL missions. Some people say, well, you know, what's the difference between SSC and SSTL? What have SSC done on the SSTL missions? All the little red crosses on there show where we've flown payloads or carried out experiments on the mission. So pretty much every up to now has some involvement with SSC. SSTL become more commercially focused. We recognise that there's a requirement to carry on this sort of technology demonstration in space, and so that's something we're looking forward to in the near future. We have a very large body of students actually within the Space Centre, something like 50 PhDs currently, if we count all of them in continuing status and so on, and similar sorts of numbers of undergraduates and postgraduates in our MSc and undergraduate programs. And so space education is very much part of what we do, both within the formal programs of the university, but also as short courses to industry. And indeed, that activity has built up a lot in the last year or so. We've carried out support of SSTL's what we call KHTT programs, know-how technology transfer programs, most recently with SUPARCO just last month. And that, again, is a continual relationship that we have with SSTL. Looking at the funding the Space Centre, that comes from a variety of sources, some from the UK, but the majority actually through industry and through overseas activities. So we actually have a broad spectrum, and you can see there the sort of breakdown. About a quarter actually comes from UK government sources. The rest, 3/4, actually comes from other institutions. But we work very with the large space agencies, with some of the military people and so on. In terms of what we do, Earth observation space science has been an area that we've supported, both in producing new instrumentation, also carrying out new techniques in space. And here's a list of just some of the things that are ongoing at the moment. And you'll see in the poster presentation some of this activity, including looking at atmospheric gases, radiation monitoring, development of space radar, development of thermal infrared technology, automatic feature detection, electronic intelligence payloads. There's a whole range of work going on, and increasingly work in robotics, looking at planetary exploration from Moonlight and Moonraker, where we have penetrators and landers, to fly out to Mars, which is an interesting concept. Of course, our specialism has been taking commercial off-the-shelf technologies, domestic technology, if you like, and putting that into space, and there's been good success in that. The challenges still remain. This technology is not designed to work in space, so part of the challenge to us is how to make it do so. But in using these technologies, we've driven down the size of spacecraft considerably. Those of you on the tour of the Space Centre will see our latest PCB-SAT, which is literally a sort of little square about that sort of size. And my colleague Tanya is working on single-chip satellites, so potentially one could mass-produce these by the million if you wanted to. In terms of other bits of support, we did the radiation design and protection of Giove, and that's been very successful. Also, we're participating in the monitoring of the environment out there. I've just come back from presenting those results in the US. And, of course, we've also supported the DMC missions in terms of calibration of the instruments and so on. Our students have recently gained some new facilities. In fact, they've been directly involved in the production of those facilities. And what used to be the old SSTL Mission Control Center is now the SSC Mission Control Center. And we have the capability of receiving and even transmitting data to satellites and designing and building satellites. At the moment, we're using that for the development of PalmSat and for the GENSO project. Again, a busy slide. The work in the Space Centre has been recognised around the world, and we sort of continue to push that. And there have been a number of firsts from the centre, including what one might argue is the first modern microsatellite with USSat Oscar 9, right down to the SNAP mission in 2000, which was a very capable nanosatellite, and now down to this sort of PCB-SAT idea. So there's a sort of drawing of where we're going on that. Ironically, as we go smaller and smaller, our colleagues in SSTL seem to be going larger and larger, so that indicates commercial pressures that companies face to kind of have bigger and bigger platforms, still pursuing the idea of pushing the cost and the technology down. And of course, it was the technology we developed for SNAP which actually has made the more recent missions possible. Rapid Eye, DMC, GOV all use SNAP-type technology to reduce the size of the avionics but increase the payload volume. So in summary then, SSC and SSTL have a strong and will continue into the future, that we generate the sort of futuristic which SSTL can exploit, and in turn we get access to space through SSTL type missions, but also get access to real world problems, which is useful for our students. And indeed many of our students, once they've graduated, become employees of SSTL, and that's happened a lot recently. So thank you very much.